Haha, it's West Virginia. Nope, it's not. Okay, but I do have joke of the day because it is the best part of the day. Did you know that protons have mass? I didn't even know they were Catholic. But what I do know is how to solve linear equations by multiplying or dividing. So we're going to continue to look at linear equations in one variable, and we're going to continue to look at the types of equations where it only takes one step to solve that equation. But we need to recall those golden rules of algebra in order to be able to solve these equations. And remember, the golden rules of algebra say, do unto one side as you would do unto the other side. Remember that idea of the pan balance, that your equal sign is this fulcrum that's in the middle of the pan balance, and one side of the equation is in one pan, the other side of the equation is in the other pan. And so in order to keep it all balanced out, you got to make sure that you do the same thing on both sides of that equal sign. The second of those golden rules is to undo what has been done to the variable in opposite order. So we're going to take a look at it. We're going to say what's already happened to that variable, and we're going to do the opposite. Remembering, that means we're reversing the order of operations, which yet again is not going to be critical yet, but here in the next couple of videos it's going to be amazingly important to know those order of operations to be able to reverse them, because we're going to look at multi-step equations. These right now are just one single step is all it takes to solve it. But let's go ahead and dive into it. So in each of these examples, notice here's my variable c, and I'm going to ask myself, what has been done to that c? Well, remember that when things sit right beside each other, that indicates multiplication. So that c has been multiplied by that 7. Well, what's the opposite of multiplying by 7? Exactly, dividing by 7. So I'm going to divide this side by 7, and 7 divided by 7 is 1. It cancels out and gives me that c all by itself like I want it to be. And that means I'm going to divide this side by 7 as well, giving me a negative 10/7. Now, always simplify a fraction if you can. Will that fraction simplify? No, not at all. You can turn it into a mixed number if you want, but you certainly don't have to. If you start with a mixed number, definitely end with a mixed number. But we didn't start with a mixed number here, so we just need to guarantee that the fraction is simplified, which we already did. Now remember, you can check your equations. I'm going to check this one, and remember, the check simply says, well, I know that c is this. So if c is this, then that means I should be able to take this, I should be able to plug it right in there where that c is. So that's what I'm going to do. Now it was 7 times c, but now instead of c it's going to be this. 7 times the negative 10 over 7. And when I do that multiplication, I better get a negative 10. So let's do that multiplication. And remember, when you multiply fractions, you cancel on those diagonals. I'm going to cancel on them. There's that gang symbol again. And notice that these 7s are going to cancel out completely, leaving me with a negative 10 on the left and a negative 10 on the right. The left and the right sides are the same, so that says, yep, because I have truth, that means this answer absolutely is correct. So let's take a look at another one. Notice again, here's the variable right there, that y. And I'm going to ask myself, what has already been done to that variable? Again, sitting up against means multiplication. So that y has been multiplied by a negative 26. So the opposite of multiplying by a negative 26 is to divide. And so I'm going to divide this side by a negative 26, and I'm going to divide this side as well by a negative 26. Negative 26 divided by negative 26 is 1. That gives me the 1y that I wanted. Now notice that I as well multiplied by, or divided by a negative. That's because I want a positive 1 variable. Positive 1y, positive 1c. I don't want any negatives in front of there, so I'm going to divide that negative out as well. And now when I divide by negative 26 on the other side, 884 divided by a negative 26 is going to be a negative 34. And remember, this says y is a negative 34. So I can check that, and when I do, remember, that simply means that wherever I see a y, I'm going to put that negative 34 in its place. It's going to go right there. So that on the left, I have that 884. On the right, a negative 26 times the negative 34. Well, negative times negative is definitely positive. And in fact, 26 multiplied to 34 really is an 884. Because that's a true statement, that means, yep, that is right. All right, let's look at a few more of these, because you know I want you to be very good at it. So we have several examples. All right, so up here, notice here's the variable x, and I'm going to ask myself, what has been done to that variable? Well, there's a negative sitting in front of it. That negative sitting in front indicates multiplication, but what exactly has been multiplied there? What is sitting there? Yes, it's a -1. So when you don't see a number there, it's understood to be a 1. So we've taken that x, we've multiplied it by a -1. What's the opposite of multiplying by -1? Absolutely, dividing by a -1. So I'm going to divide this side by a -1 and this side as well by a -1. Now -1 divided by -1 is a +1. That's exactly what I wanted to happen because that gets that x, number 1 by itself, number one by itself, but as well makes it a +1, and that's what I needed. Now a +12 divided by a -1 is a -12. Now I'm going to check it. And so when I go to check it, that simply means that I'm going to take that -12 and I'm going to put it right here, which means the opposite of -12, because I plugged that -12 in for the x. So the opposite of -12, or in other words, negative times negative will be positive. And is that what I needed to get? Is that what's on the right-hand side? Absolutely it is. So I've created a true statement, and that means that the answer that I got there really is right. Now notice here that when you divide by a -1, basically what happens here? Yes, notice that that -x turned into a +x. That +12 turned into a -12. So dividing by a -1 basically just changes all the signs. And that makes life very easy on you. So you can divide through by the -1, or you could say, guess what? That's just going to change the sign of everything on the left, the sign of everything on the right, and I'm just going to go change all the signs. That's a little shortcut that you can take. So with that shortcut, take a look at this one. Here's that z. That notice has a -1 sitting in front of it, which does indicate I'm going to divide by a -1 on both sides. But we just learned the shortcut is, okay, that just simply means change all the signs. Change the sign of what was on the left, change the sign of what was on the right. And again, if we go to check that, we plug that 26.5 in here, the opposite of a +26.5, sure enough, is a -26.5. We know that that's the right answer. Now notice in this one, we're switching gears a little bit. What has been done to this variable? What does this bar mean? We've talked about this before. What does the bar mean? Yes, it means division. That's what we did here. We divided here, we divided here. The bar always means division. So we've taken this variable, we've divided by 4. So what's the opposite of dividing by 4? Absolutely, multiplying by 4. So I'm going to multiply this side by 4. And here again is that idea of being able to multiply those fractions. There's that gang symbol again. I'm going to cancel on those diagonals. And so 4 and 4 will cancel out completely, and I'm left with a C. And what I do on this side, I have got to do on the other side. So I'm going to multiply this side by 4 as well. And 16 times 4 will give me a 64. There is my answer. Now, I can check this one as well. And in order to check it, just like before, I'm going to plug that 64 everywhere I see a C, which means right here. So I'm going to do 64 divided by 4. And what is 64 divided by 4? Yeah, in fact it is 16. So once again, I've created truth. That means this answer is correct. All right, one more, and then we will take a look at the application there. So once again, here's that variable. What has been done to it? It has been divided by a 6, so I'm going to multiply by 6. And there's the idea of canceling on those diagonals because I'm multiplying fractions. The 6's will cancel, giving me the m by itself. And like I said before, I like examples like this because we get hung up thinking that variable has got to be on the left. It doesn't. It's okay for the variable to be on the right. The whole idea is I want the variable by itself. And I want to have a +1 in front of it. Not a -1, a +1. So I'm going to multiply by 6 to get it by itself, get that coefficient to be a +1, but that means I have to take this side and multiply it as well by a 6. Now, positive times negative will be negative, and 6 times 18 will be a 104. So now I'm going to check my answer to make sure that I've got it right. And remember, what that indicates is I'm going to take that 104, or wait, no, oh, I am so sorry. That should be 108, not 104. My humblest apologies. Okay, so now when I go to check it, and I put that 108 right here where that M is, so I have a -108 divided by 6. Now, negative divided by positive is definitely negative. And what's 108 divided by 6? Yeah, sure enough, it's 18. So I know that my answer is correct. That's the beauty of these equations. You can check all of them to make sure that your answer is right. You just take what you got for the variable, plug it back in where the variable is, follow those order of operations, and see if the left side and the right side come up to be the same. If they come up to be the same, you've created truth, and that means that your answer that you suspected was the answer really is the answer. This is great that you can solve every one of these. Now, let's take a look at an application of this. Notice in this application it says our beach house, we're going to head to our beach house and take a little vacation. It is 455 miles away. And we want to know, okay, if we drive 70 miles an hour down the interstate and we keep a consistent speed of 70 miles an hour and we don't stop, how long will it take us to get to that beach house? Now, in order to solve this, we need to understand a little formula that helps us figure out distance in terms of rate and time. And it's the formula D equals RT. Distance equals rate times time. Distance equals rate times time. We need to utilize this formula in order to be able to solve this. Now notice in this case, what is the distance? Yes, it's 455 miles. So I've got 455 equal to, now what's the rate? Yes, the rate is the speed, 70 miles an hour. Now, I want to point out here, this is 455 miles, and this is 70 miles per hour. Okay, miles per hour, there are units on that one. Now, the reason I want to point that out to you is because, remember, it's rate times time, so that's going to be multiplied to the time. Now, do we know that time? No, in fact, that's what we're looking for. We want to know how long will it take? That's the t. So we're going to let t equal the time in hours that it's going to take to get there. And the reason I want to point that out is because this is time in hours. And notice this idea of being able to cancel on those diagonals. And if we cancel on those diagonals, notice what happens is the hours and the hours will cancel out completely, leaving us with miles and miles. So we know we're setting this up correctly. Here is our equation. We just need to solve it. And like we saw in the previous examples, how am I going to get that t by itself? Notice it's already been multiplied by 70, so the opposite would be to divide by 70. So I'm going to divide both sides by 70, and 455 divided by 70 is going to be 6.5. 6.5. And it's 6.5 what? Because this is a real world situation. We need those units in there. Yes, 6.5 hours. And that is how long it will take. And we can check this one. If we take our 6.5 hours and we multiply it to 70 miles an hour, 70 miles per hour, notice that when we plug the hours in here, those hours will cancel. They'll leave us with miles. And 70 times 6.5, sure enough, is 455. So this is an application, and there are many, many other applications too, solving your equations using multiplication and division. But what I really want to stress to you, like I keep stressing in all of these videos for solving equations, is the two golden rules. If you can keep these two golden rules straight, you can solve any equation no matter how big it is. Keep that pan balance in mind. Do the same thing on both sides of the equal sign. Do unto one side as you would do unto the other side. And reverse those order of operations. Undo what has already been done to that variable, but undo it in opposite order. I hope it helps. Have a great day.